So the next question number 11. Please go through the question. That is okay. So the next question number 11. Which are the following d orbitals not used by central atom? Here all are px5 category, right? They all are px5 category. So in px5, let me find the total valence electron. Valence electron of phosphorus, that is 5. Halogen, that is 7. And 7 into 5. The answer is equal to 40. With the total 40 valence electron divided by 8, the category will be 50. 50. So the total VSEP 5 plus 0, 5, which means the hybridization will be sp3d. So they all have hybridization of sp3d. Okay. So they all should use the d orbital. So the following with which is not using the d orbital is there is none of this. Okay. Because everyone want to use the d orbital. Ready? So moving to the next question. Next question, that is an element X can form different formulae. XCl3, X2O5, Ca3, X2, but does not form XCl5. What is X? Okay, actually, this is boron, this is aluminum, and this is nitrogen, and this is actually phosphorus. Okay, that's a printing mistake. So let me answer this question. XCl3, what is the oxidation state of X? Oxidation state of X is these 3 chlorine have to offer -3, so X have to offer +3. So X, the oxidation state is +3. What about the next? X2O5. Okay, so these have to offer -10. So here is +10. But the +10 is from 2X. So a single X have oxidation state of +5. The next is Ca3X2. 3 calcium have to offer +6. So here will be -6. So -6 from 2X. So X have to offer -3. So it is clear that your X can form these following type of oxidation state. But X do not form XCl5 means, what is the point that you get from that? Do not form XCl5. In XCl5, the oxidation state is +5, but we all know that X can show the oxidation state of +5. So this is not mean. This is not mean here. They mean that the X can't accommodate 5 chlorine at a time, which means covalency of X will not be equal to 5. So this is the common oxidation state shown by 15th group element. So our expectation, either nitrogen or phosphorus. But phosphorus can form a PCl5 category, but NCl, we all know that due to the absence of d orbital, NCl5 is not possible. So there is no doubt your choice is nitrogen. So the choice is C. Okay. Moving to the next question. Fine. The next question, that is BrO3 minus is isostructural with which of the following? I already told you that isostructural means similar structure. Similar structure means similar valence electron. Okay, so 3-oxene, 3-oxene. So this may be the chance. So let's find the valence electron of BrO3 minus and XO3 minus. If they all have similar valence electron, then their structure will be similar. Okay, the effect due to 3-oxene is same in both cases. So here the valence electron of bromine, that is 7, plus a negative charge means 1 electron. So this will be 8. Here this is not Xc. xenon itself can form 8 valence electron. So all in these two examples, valence electrons are same. So if the valence electrons are same, they are isostructural. So XeO3 will be the answer. Okay. Moving to the next question. Question number 40. Fine. The molecule AB has bond length 1.61 Armstrong, dipole moment 0.3 d. Then the fraction of charge on each atom. Fraction of charge on each atom. So we know that dipole moment is equal to Q into D, right? Dipole moment is equal to Q into D. And what do you want to find? You want to find the fraction of charge on each atom. Okay. So listen. So let's find the total charge. Total charge. Okay. Fine. So in order to find the total charge, you have to divide the dipole moment with the distance. Okay. So what is a dipole moment? 0.338 divide, and you know 1 divide is equal to 10 raised to minus 8 ESU centimeter. So this is 0.38 into 10 raised to minus 18 ESU centimeter. And what is the distance? 1.61 Armstrong. So 1.61 into 10 raised to minus 10 centimeter. Okay, so we get the charge. So the total charge is actually 0.38 into 10 to the power minus 10 divided by 1.61. ESU is the answer. Ready? Fine. So 0.38, 1.61. Fine. So what is the double of 38? 38, the double is nearly 1.88. Fine. So this is nearly 1 by 4, right? If this is 40, the answer will be 1 by 4. So nearly 1 by 4, 0.25. So approximately that is 0.2 into 10 to the power minus 10 ESC. Okay. If this is a total charge, we know that charge is equal to N into charge of electron, right? The total charge will be the number of charge possessed by atom into the charge of electron. That you know, integral multiple. So here the total charge is 0.2 into 10 raised to minus 10. And N into the charge of electron, that is 4.8 into 10 raised to minus 10. So N is equal to 0.2 divided by 4.8. 10 raised to minus 10 get cancelled. So 2 by 48. 2 by 48. If having 0.00, then it will be 200 divided by 48. 200 divided by 48. The answer is 48, nearly 4. Okay. This may be nearly 0.25, I think. Okay. So nearly the value approximately 2. So 0.05 will be the answer. Okay. Fine. So the fraction of charge is 0.05. The next question. The compound which can show a maximum dipole moment. So we know that this is a minus R group. So its dipole moment will be in this direction. This is a minus R group. So dipole moment will be in this direction. This is a plus R group. Dipole moment is in this direction. So that can get cancelled nearly. Similarly, this is like this. But in the case of para, we already discussed the theory. In the case of para, this is to the top and this is a plus R group, this to the top. So this have a greater net dipole moment. Okay, so one with the minimum dipole moment will be ortho because the vectors are nearly cancelled. So B will be the choice. Okay, fine. Okay, moving to the next question. Which of the following is a wrong order with respect to the property mentioned? O2, wait, let me check that question. O2, 2 minus, O2, O2 plus. So this is actually 2 minus. Fine. O2 2 minus, O2 O2 plus. We know that this have pi star 2p x1 equal to pi star 2p x2. So unpaired electron is 2. The number of unpaired electron is directly proportional. Number of unpaired electron, that is directly proportional to paramagnetic behavior, right? Fine. So this have 2 unpaired electron. If 1 electron is lost from the O2, then this electron may lost. So no doubt there will be n equal to 1. If 2 electron gained means this become 2, this become 2. So n will be 0 here. So one with the greater paramagnetism is O2, then O2 plus, then the last is O2 minus. So this order is not okay. So the wrong order means this may be the choice. What about the next? Bond angle. If the size electronegativity of central atom decreases, bond angle decreases. So the concept is okay. What about the bond energy? H2, what is the next choice? H2 plus, fine. H2 plus and He2 plus, right? Yes, He2 plus. So let's consider the bond order. The bond order is 1 here, bond order is 0.5 here. And the next, what about the bond order in He2, right? He2 plus. So actually there is helium, 2 electron. Helium, there is 2 electron. He2 means a 4 electron. So will be 3 electron. Okay. 3 electron is here. Here only 1 electron. So here the bond order is also 0.5. Okay. So as bond order decreases, bond energy nearly decreased. So this will be the bond energy order. Here this is correct. This is actually NO2 minus. So this is correct. Okay. So the better choice is A. So the next question. The incorrect statement about N2H4 and N2F4. That is the question. N2H4 and N2F4. Okay. In N2F4, d orbitals are contracted by electronegative fluorine, but d orbitals is not contraction in N2H4. You have to know that both have similar structure. This is N2H4 and this is a molecule N2F4. Okay, where nitrogen have no d orbital, fluorine also have no d orbital, hydrogen also have no d orbital. So there is no d orbital, there is no significance of the idea d orbital in both. Okay, so since there is no d orbital for nitrogen, fluorine, and your hydrogen were the 3 elements involved in these molecules, no d orbital, so there is no significance for this one, which means this one is wrong. The next is NN bond energy of N2F4 is more than NN bond energy of N2H4. Okay, so now next you have to know a rule called Benz rule, which determines the S character and P character of orbital. Okay, if there is a bond to the less electronegative, if there is a bond to the less electronegative atom, then its S character increased. So consider the bonds of nitrogen, which is bonded to 2 hydrogen, where electronegativity of hydrogen is comparatively less than nitrogen. So this bond have greater S character. Greater. These all are some kind of sp hybrid orbitals. Okay, sp2 hybrid orbital actually, right? Yes. So the characteristic distribution of the percentage distribution of S character If the bond is towards less electronegative atom, where its S character increased. So here the S character of this bond are increased. Automatically, here the P character increased. Okay, we all know that. For example, if you have sp2 hybrid orbital, well, these all have a fixed amount of S character and P character. But if the bond is towards, or if there is electronegativity, then there is small distortion in S and P character. If the bond is to the less electronegative atom, where its S character increases, automatically the P character of another bond increases. So this bond will be longer. Since P character increased, S character may shorten the bond, where P characters increases the bond like that. Similarly, consider N2H4, NF4, N2F4, where these bonds are to the more electronegative fluorine than nitrogen. So this bond have more P character. Automatically, this hybrid orbital may have a greater S character. So this may shorten. So this will be the shortest bond. Okay, fine. So keep that idea, and this is based on Benz rule. Ready? So fine. So the NN bond energy in N2F4 is more than NN bond energy in N2H4. Here the N2F4, the NN bond energy is higher. That's correct, because N2F4, the NN bond is short, so have high bond energy. So this statement is okay. The next is NN bond length is in N2H4 is more than. Here the bond length is more than this one. That's wrong. NN bond length in N2F4 is less than N2H4. That's correct. So the wrong statements are 1 and 3. So the choice is B. Okay. Fine. Move to the next question. Consider the next question. Okay. Question number 18. Which are the following compound BF bond length is shortest? So BF4 minus BF3 coordinated with the nitrogen, BF3 coordinated with the carbon, etc. Right? Yes. So this is an independent BF3. If you have an independent BF3, then what is the speciality means? Your independent BF3 have a back bonding, because boron have vacant orbital like 1s2, 2s2. 2p1 is the configuration. 2p1 means this is the configuration. So some orbitals are vacant there, right? Some orbitals are vacant there. Ready? Okay. So there is a vacant orbital in your what? Boron. So your fluorine can coordinate easily. So what is the speciality mean? If the fluorine coordinated to that particular one, then there may be the chance for a double bond character for every fluorine, because this may possible in this fluorine or this fluorine or this fluorine. So the bond length of BF bonds in BF3 is not actually single. It have a partial double bond character. Then what about BF4 minus? In case of BF4 minus, in case of the molecule BF4 minus, BF3 with F minus, right? So F minus donates electron to the boron, so that there is no chance. If this orbital is filled with the electron, external electron, so there is no chance for back donation. Exactly the very same in here also. There is a coordination of what? There is a this arrow is like this. Okay. There is a coordination of electron pair from nitrogen to boron. So there is no chance for the back donation from fluorine. These donations are from external agent. Okay. So in these all three all three, boron and fluorine may have what? Single bond. But in a pure BF3, there is a chance for back bonding, which decreases the bond length by increasing the bond order. Okay. So the choice is C. Ready? Next question. Our next question. Which of the following statement is incorrect? O2 is paramagnetic, O3 is also paramagnetic. O2 is paramagnetic, O3 is also paramagnetic. We know that O2 is paramagnetic because there is actually pi star 2p x1 equal to pi star 2p y1. Pi star 2p x1 equal to pi star 2p y1. Ready? Fine. But what about O3? Is O3 paramagnetic? No. O3 is a diamagnetic species. Because we know the structure of ozone, where all electrons are paired. The next, different observation found in their bond length of NO and NO plus. NO and NO plus. So there is difference in electron in NO and NO plus, CO and CO plus. So if you are writing the molecular orbital configuration, there is a difference in the bonding and anti-bonding electron for NO and NO plus, like that CO and CO plus. So their bond length, bond order will be different. So the bond length will be different. Okay. Next, B2 is paramagnetic. C2 is also paramagnetic. B2 paramagnetic. C2 is also paramagnetic. C2 is not paramagnetic. So B option is correct. Where A is wrong, C is also wrong. Okay. So A choice and C choice all are wrong. Okay. Others are okay. Next question. So there is actually two choices. Okay. A, which is a wrong one, and C, that's also wrong one. Ready? Next question. The very same question, very same kind of question, you based on Ben's rule. O2 F2. O2 F2. O2 F2 is an unstable yellow orange solid, and H2O2 is a colorless liquid. Both have OO bond and OO bond length of H2O2 and O2 are respectively. Okay. So if we have H2O2, what is the structure? H O O H. What about H2O F2O2? F2O2 or of O2 F2. Structure is F O O F. Fine. Now consider the Ben's rule. As per Ben's rule, this is with a less electronegative hydrogen. So this bond have greater S character. Automatically, this bond have greater P character with respect to this oxygen. Okay. So a longer bond is this one. Here, this is connected to more electronegative fluorine. More electronegative fluorine. So this have greater P character. Automatically, this have greater S character. So this is a short bond. So O bond length in H2O2 will be greater than O2F2. So here the values are 1.22, 1.48. So H2O2, the O bond length is longer because the O bond length have particular P character. But F2O2, it is comparatively shorter. So we can choose respective longer, shorter. That means 1.48, 1.2. Okay, even though we are not knowing the values. Okay. So the next question. So next question. If theta is the theta would result in the maximum dipole moment of triatomic molecule X5. If bond angle is theta, would result in the maximum bond. Fine. If the bond angle is theta, we know that if there is a bond like this, XYY, if this angle is theta, then the resultant dipole moment, that is root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Fine. So the value of dipole moment depends on cos theta. Okay. If theta equal to 90 degree, cos theta equal to 0. Cos 90 equal to 0. Okay. Cos 120. Cos 120. The answer will be less than 1. Negative number, right? Because the second quadrant cos is negative. Cos 150, also the value less than 1, negative value. This also less than 1, because these all are in second and third quadrant. Okay, actually that's all are in second quadrant. So second quadrant, the cos value is negative. So if this is negative, means this term become negative, which decreases the dipole moment. If this is 0, means there will be at least this much magnitude. So greater will be for theta when it is 90 degree. Okay, fine. So next question. On to the next. Which of the following statement is correct? PH6 not exist. That's correct. P pi D pi bond present in SO2. SO2 actually, this is the structure of SO2. Okay. So what is the hybridization? This is actually the structure, main structure. So hybridization sp2. So consider the molecule sulfur. Consider the sulfur molecule. Okay. Sulfur molecule. For your sulfur molecule, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4, 3d vacant. Okay. For sp2 hybridization, this electron is excited to here, so that the orbital will be 3s1, 3p3. This orbital should be unpaired, then only you obtain the sp2 hybridization. If it is paired, then that will be a long pair. Okay. Now, fine. This is actually paired, right? This is actually paired because this brings the lone pair. Here actually 3p4. So this electron excited to the 3d orbital. Fine. So this will be the configuration. Okay. So this is used for hybridization, which brings the sp2 orbitals, and these two are unhybrid orbitals, a p orbital and a d orbital. This brings the 2 pi bonds. You all know that oxygen have only p orbital, so this pi bond may be between pi of oxygen, p pi of oxygen with the p pi of sulfur, and this may be with the d pi of sulfur with the p pi of oxygen. So that's perfect. P pi bonds are present in SO2. The next is SCH4 and CH4 have same shape. So here fluorine hydrogen effect are same because bonding sense, in bonding concept, halogen, hydrogen have similar effect. Selenium offers a valence electron of 6, whereas carbon offers a valence electron of 4. So this is not equal. So they do not have same shape. So 3 is wrong. I3 plus have bend shape. What about the valence electron of I3 plus? Iodine 7 into 3 plus 8 minus 1. So that's 20. 20 electron divided by 8, that will be 220, remainder 4 divided by 2. So that will be 2 category, just like water. So that will be bench shape. So this statement is also right. So actually, this is question number 22, right? Fine. So which of the following is correct statement? 1 is correct, 2 is correct, 4 is correct. So D will be the choice. Okay. Fine. So next question. Which of the following has smallest bond angle in molecule? Smallest bond angle in molecule. Fine. This having a bond angle of 104.5 degree. H2S, the bond angle is less than water. This nearly 90.2 degree or 92 degree. Ammonia, the shape is pyramidal, so bond angle 107 degree. SO2, it is given in Ncert textbooks. The shape is hybridization sp2. These all have hybridization sp3. These three have hybridization sp3. This have hybridization sp2. So if the percentage of S character decreased in hybridization, then bond angle increased. Sorry, if the percentage of S character increased in hybridization, bond angle increased. Okay, anyway, smallest bond angle in the molecule, water, where the bond angle of H2 is much less than water, since the central atom is less electronegative. Okay, so moving to the next question. The correct order of bond angles: smallest first. Okay. H2S, NS3, BF3, SiH4. H2S, we know that is a 90.2, a 92 degree approximately. That's not 90.2. Always I'm writing 90. This is 92 degree nearly. Ammonia 107. BF3, you know, nearly 120 degree. SiH4, since silicon, that is similar to carbon in bonding. So this is 109.5 approximately. So greater bond angle is for sp2 hybridized BF3. Then this one. So the choice, I think, A. Okay. So the next question. Which of the following is a unit conversion of dipole moment is correct? 1 dB is equal to 3.335 into 10 raised minus 30 coulomb. B is correct. That's a direct question. We already know that. Okay. Next question. Which of the following hydrocarbon have lowest dipole moment? This is a trans molecule. Planar. Okay. This have relatively low dipole moment. This is a linear one. A linear one, there is no compromise. In case of a linear one, there is no compromise. Perfectly, the dipole moments gets cancelled. Okay, fine. So this will be one with the very low dipole moment. There is some net dipole moment may be there. Okay, in your Ncert, it is given that dipole moment of trans butene is nearly zero, approximately zero. This is actually zero. Here no value of zero, because here it is hydrogen, no net polarity, but here is alkyl, there is a dipole moment towards this side. Like that, here also. Here two hydrogens, here is a methyl, so net dipole moment towards this one. So one with a very low dipole moment, that is 26 will be the answer. Okay, fine. So the next question. 26, the answer will be B. Okay, answer is B. Move to the next question. The total number in OF2, the total number of bond pairs, lone pairs, and electron. OF2. What about the valence electron of OF2? Oxygen have 6 valence electron, fluorine 7 into 2, and the answer is 20. If 20 divided by 8, 2, 20, sorry, 2, 16, 4, 4 divided by 2, 2. So 2 bond pair, 2 lone pair. Shape is like water. Unlike hydrogen, fluorine will be surrounded by 3 lone pair. So 1, 2, 3, 4, 5, 6, 7, 8. 8 lone pairs, 2 bond pairs. So bond pairs 2, lone pairs 8. Choice is B. Okay. Move to the next question. Which of the following is incorrect? A pi bond is formed when sigma bond already exists. That's correct. A pi bond is formed overlapping between p and d orbitals. That's also correct. A pi bond is formed by overlapping of hybrid orbitals. That's wrong. Hybrid orbital never make a pi bond. A pi bond is formed by the lateral overlapping of atomic orbitals. That's correct. So you have to identify the wrong statement. So the choice is C. Okay. Question number 29. The molecule containing sigma sp3 sigma sp3p. Oh, so here there is 2 single bond. sp3 will be the hybridization. Here also sp3 hybridization. So I think this is a choice because here 2 single bonds are there. All single bonds. I think you know how to find the hybridization of organic molecule. So single bonds are sp3. So this is sp3. So have sigma sp3. And now you need sigma sp3p. So this is a sigma sp3s. This is overlapping of sp3s. But this is overlapping of sp3 with the p orbital of fluorine. Fine. So this will be the answer. Okay. Over here there is 2 carbon, but this carbon have sp2 hybridization since there is the carbonyl group are sp2 hybridized. Okay, I think you know how to find the hybridization of organic compounds. The next is bond angle between 2 orbitals is 107 degree. If bond angle between 2 orbitals of 107 degree, then it have a shape of ammonia-like pyramidal. Okay, the pyramidal shape, the hybridization will be sp3. sp3 where the percentage of S character is 25%. So choice is D.